Hello and welcome to the VEST webinar series. I'm Frank Newsom, your moderator for today's webinar session. And today we'll introduce you to manifold design efficiencies that can be achieved utilizing the MDTools Library Manager. This webinar will last approximately 30 minutes. You'll be able to submit your questions or comments at any time during the webinar by posting in the questions section located within your webinar control panel. Questions may be answered as they're posted, or we will try to address them in the last 5 to 10 minutes of the webinar. Note that today's session is being recorded and that the audio is muted for all attendees. If you're experiencing any technical issues, please use the chat window to alert our support staff. Now it is my pleasure to introduce our speaker for today's webinar session, Carlo Molon. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. Carlo?
Hello, Frank, and thank you all attendees for joining today's webinar. The topic today is Library Manager. So I have prepared a bit of material and I hope we will be able to cover all. When we speak about library management, of course, we need to be aware of what is the implication of what we do in the library and the consequences in the machine drawing for MDTools. As you know, as MDTools customer, we provide a huge library of cavities. Sometimes for new customers, I recommend not to start from that huge library, but to start from a blank library and import what you need. The reason for that is sometimes we lose really track of what is available in the library, and it sometimes could make sense really to start with a fresh library. We have customer that built really a library from scratch that has nothing to do with the standard library. So if you are interested in this process, if you want to have a clean library, we will be able to provide you a clean library to start with. And in my case, I will just open a library that I have put into my webinar February, and that's my MDTools library webinar. As you may be aware, MDTools library is the standard one is based on a SQL on a Access database. We also have the possibility to move to an SQL library. The library practically, if I go to this path here, is made of several databases. In an SQL environment, there will be just 3 databases. VEST provides the latest update library in the website. Let me go to VEST websites. Yes, we go to support, service packs, and in any MDTools for Solvus or Inventor, that will not make any difference. MDTools Library Manager, there is a library download. So there you can download the latest version of the library. Please remember, we still have a decimal separator issues. So if you are using dot as decimal separator, you will need to go for dot decimal separator and comma for comma decimal separator. So let's start. Like you see here, I'm changing the path to this library, which is empty, nothing is there. In order to build a library, really starting from scratch is not convenient. So it is possible to import cavities from other libraries. And I'll start small. Normally, since I'm working in a metric environment, I'll need for sure bolt holes. So I'll use this small icon, which is the import cavity. And this commands will allow you to import cavities from other libraries. So either you have your supplier with MDTools providing you some cavities, or you use the library that is coming with latest release of MDTools. You can select the path, and I have downloaded the library somewhere into my CVest folder, and that's my MDTools library. This is a standard library which I have. Now, when you import, you could import the entire database. It does really not make sense, but we can start importing maybe the bolt hole metric. You can select which one you need, or you can say select all and create the library if not present, and then you import in the library. So similarly, we can import maybe all the BSP ports, and maybe I import some HDAC valves, HDAC cavities, and it may take slightly more if there are many cavities, and so on. Really, you can import, let me import some orifice plugs, because I want to show you a bit of orifice plug later today. So when you do that, you are really starting to build a database which is clean. Feel free to rename the cavities as you want. In my standard library, if you attended to some webinars we made this year or last year, if you notice, my library is different from what we offer regularly. I really, since my library starts from the original one of MDTools, I don't need all those cavities. I normally put a prefix, maybe 0, rename, yes, or 01 for BSP. In this case, you put a prefix, and then the folders will show up alphabetically. So 0 will come before 1, before 2, and so on. So in this case, you can really sort the libraries according to your preferred style. It is possible, of course, to enter into a library and select a cavity and change also the information that will show up in the machining drawing. Here there is a big decision you should make in order of the type of machining drawing that you are going to perform in your as drawing standard for your organization. Let me start a new block so I explain what is the difference between these two approaches. So first, in my MDTools, I will select this library, the one I am working on. Remember, if you change the default library path, make sure that the MDTools is pointing to the same path as the library manager. So now if I create a new block, and we'll do some test with this block, and I put just a BSP port, just a 1x2 BSP port, and I call it port number P, and insert in the drawing. And maybe in my drawing, I change this diameter to 50. And let me save it somewhere into my block. And let me put into my webinar February. And I call it block 1. Yes. Now, if I make a machining drawing for this, and place the views of my block, and try to make the machining call out for this, then I can see really lot of information: drill, form port, tap. If you adopt this type of drawing with machining call out, really my suggestion is remove drill. It's clear it's a drill, so you don't need a prefix drill. Remove tap. When you type G1x2, then it's enough, easy to understand. So if you use a drill chart, then really what you want is to have all the information for a drill chart. But if you use this kind of drawing, then you should get rid of all the information. So what I normally do in this case, I will get rid of this. I'll put, maybe this is a spot face. I call it into Italian languages. LAM, it means spot face, step 0. Then I put the G1x4 here, step 1. And if you want, you could also put an additional intermediate step, like step 2, which is the tap drill, step 12 and step 2. So let's see what happens if you describe the cavities like this. Dollar step 2 means in the diameter means when MDTools will find something in the step 2, it will write the diameter, and the depth if it is in the column depth. So this is how we parameterize the information that will go into the machining drawing. Let me save it. And now let me add this cavity to the same block. So we go to the block and we add the G1/4, which I call it item 2. Well, let me put in the same face. And let me change the diameter. Maybe I put it as 8/50. And we go to the block. And now the block will ask me to update the drawing, which I can do. I update my drawing. Now, as you can see, the information are more compact. Diameter, spot face, and the thread. This is clean. In case of machining callout, I'd rather go for more rows instead of long information. In case of drill chart, it's better to reduce the number of rows because eventually the drill chart may become very, very, very long. So one big decision when you build a library is really related to the type of machining drawing you will perform. My standard is now going towards machining callouts. So all the library that you have seen in the webinars and I normally do is tending to work well for machining callouts. Then in case of drill chart, I need to do something else, and sometimes I need to duplicate the cavity in order to have a cavity that is well made for machining callouts and another that is better for the drill chart or vice versa. So that's the first part of today's presentation. The second part is, and I'll try to cover today some requests that normally come for support tickets. The second part I want to cover is how to build a new footprint, and also how to bring envelope outlines for that footprint. Let me start building a filter cavity. I have, as an example, recently I made a block where I had the need to put this filter. It's an MP filter, but it's very similar to HyDraw filters or other brand. So of course I don't need to model all this stuff, but I want to use this shape in MDTools as well into my environment. So I want to build this cavity and utilize this geometry profile for the outline. So this filter is has 2 M12 bolts, and the distance here, if you use it's AutoCAD, this one is AutoCAD. Unfortunately, what you see here cannot be done in HyDraw CAD because HyDraw CAD has no possibility to be invoked from outside like we need from a library manager. So this is the distance, and let me start building this footprint. So first I want to create a new container, a new folder. So let me call it MP filter. And then I just enter into this folder, which is empty, and I go into MP filter. And I'll start from scratch. I'll add a new footprint. So when you create a new cavity, Library Manager will require a selection of the type of cavity you are building. So so in this case, let me go to interface pattern, and I'll name it that I don't remember now exactly the name of the filter. So let's call it FB500. It may be different. So the name of the cavity is what really matter in order to find it in your technical documentation. And we start with a drill or with a bolt. It's up to you. Let me start with the in of the filter. So you can put some notes. That's my catalog, whatever you need. This is to remember where you found the information for that cavity you are building. The diameter is a 16 millimeter. Let's put it 20 in the block, and 59 is the tip angle. This maximum drill diameter is very important because it will save you mistakes in case you make inclined drills or you make a drill that are too large. And again, I put $, step 0, and $step 0 as diameter, and save it. Now this will be my primary cavity of the footprint, so I keep it dimension from this cavity on. Then I edit the footprint and I start building the other drills. So I can add the port which is out, and the position is 0 on the X and 26 on the Y, and still it's a 16 millimeter by 20 by 59. And the max diameter is 16, and it's $step 0 and $step 0. And I can save it. And now I can see the two drills. Now, in order to bring the bolt holes, what you need to do is just add and import the bolts that have been already defined into the, now I think they may be, it may have gone out of the screen. Yes, those are Windows problems of screen resolution. Let me just try. Okay, there it is. It's on the other screen. Yes, sometimes we have drills. I'm working on the other screen. It seems like I'm not able to bring it. It was an M12. So let me select OK. Oh, come on. Let me do again. Let me say import cavity. I can see it. It's on the. Yes, looks like. Let me just restart the library manager. Otherwise, looks like we are stuck here. Otherwise, I import the cavity again. Let me restart the library manager. Sorry, but I changed the resolution of my screen when doing the webinar because otherwise it's not visible, and then this is a non-tested situation. Let me do again. Let me try and import again. Add import. Okay, now it's here. Bolt hole metric, and I take an M12. And the position is minus, it was 58, so it's 29 and 0, and save. It was not 0, it was 13.5. So you just change the position, and that's it. And then it's plus 29, and you do a save as. And this is the position of the two bolt holes. Now, and we can save everything, and now the footprint is made, and the footprint will have just the two bolts and the two drills. It is possible to import now to edit the outline. So the outline is possible now by importing from AutoCAD. When you import from AutoCAD, and now I think I have the same resolution issue. Okay, there it is. Now it's the dialog here. Let me get back to AutoCAD and load again the library manager. I bring it to a different screen, and then I'll bring it back again here. I'm sorry for this inconvenience. Okay. Edit outline. So I did from AutoCAD. Now the reference point, I need a reference point, which is the insertion point here, and I need the entities. So I selected the entities. If you test on your system, you will see much better. Really, my issue is here with the bad resolution of the screen. So you select all the entities one by one. When you are done, you click enter, and then you click OK. And now the geometry will be available for your footprint. And when you click save, Let me do here, save. I think Windows got much worse in all this screen scaling stuff. Save, and we are good. And save again. We can try it now in our block. So we can go back to MDTools. We go back to the block library, and we can search for all libraries and look for the MB. Well, one information is important. When you create a new folder in the same session, you will not see the library immediately loaded. Either you switch temporarily to a different library and then switch back to the original one. Otherwise, the new folder will not be visible in MDTools. So there you will see now the MP filter and FP500, which I can use into my block. And now I can use really the outline that I have defined into my MDTools. I see one question. It seems similar. What are the special feature available? Can you explain how do we do the simulation and reduce the errors during design the manifold? Well, this webinar is for Library Manager, is not to explain all the MDTools command for doing the checking of the manifold. So we may do another webinar dedicated to design checks, but these topics were covered in many other webinars last year. So today we are out of, we don't have enough time to go through also the design check command in MDTools. Let me get back to the Library Manager. And so we have defined this MP filter cavity. Now the other topic I want to describe is how flexible is MDTools with the sun style cavities. So in this case, I'll just import. So I'll do again the import for a sun cavity. Let me go to save as the MDTools library. And I'll load sun valves, hydraulic cavities, import, and close. So now let me, yes, I should have checked create a library if not present. Create library if not present. Otherwise, it will not import anything. And now it did properly. You may be aware that some cavities do have, let me take a T11A, do have a dynamic profile that show up as far as you drill down the cavity in the manifold face. Some customer really want to describe the spot face when it reaches a new level of the block in order to invoke a tool in the machining operation. So as an example, I'm going to edit this T11A and add a counterbore. Well, step 0 is already there, but it should not be a drill. Let me call it counterbore. Step 0, step 0. So as you can see, step 0 in this case, it's a diameter that may not be fully available in the block. Let's see how it works. So please notice we have a line called counterbore, step 0, step 0. So now let me go back to the block. And let me get back here. So again, it's a new folder, so I need to switch back and forth. Otherwise, it's not visible. And let me take a T11A. Let me take a T11A and let me add it to the block somewhere here. And let me copy the same cavity here. And let me change the locating shoulder in order to show up the step 0. So now, as you can see, there is a step 0 there. So let's see the difference in the machining drawing. And let's always utilize the machining callout. So this is the standard locating shoulder cavity. The standard cavity with the standard sun cavity with the default locating shoulder. So it's describing the drill and the depth is LS locating shoulder. So as you see, this is really not so easy to read. That's why I really like, in case of machining callout, to change a bit the formatting of the text. Normally for these cavities, I remove the drill. I put just the, let me show you what I normally do. Let me get back to the T11A so I show you my recommendation for this cavity. If you need machining callouts, I put remarks sun cavity, sun hydraulics, and I put just T11A here. And then, well, I just put the spot face if it is needed. Nothing else, actually, nothing else. Save. Oh, yes, I need the LS, of course. LS, and I put the locating depth step. Locating step is step 2. Save. So 4 lines because I want the machining callout to be working fine. So I get back to MDTools. I do a replace command. I replace with sun cavities T11A all the similar cavities in the block. And then I go back to my machining drawing, which will require an update. And this is much cleaner. Pre-drill, sun hydraulics T11A LS. This has no spot face, no additional counterbore. This one is an additional counterbore. So this provides you enough freedom to describe also additional steps in a cavity. So it may be used not only for the sun valves, but for any type of cavities. There is a typical valve which I also model as a sun style valve, which is the Bosch Rexroth DBD S10, DBD 10K, 20K, 6K, which I can now import. Unlike what is done in the default library, really I use a different modeling because these components behave better considered as a sun cavity. Let me show you the example. MDTools library. I take, but the similar cavity is available also for Atos, for Diplomatic, and Parker as well. Bosch Rexroth. It's the DBD6. This one. Let me just import those, and I show you how they are. DBD 10K. Although they are modeled this way, normally in this case I define them as a sun cavity, and where the locating shoulder is step 3 here. So in this case, the valve behaves better also for the assembly rules in the block. So that's a change I do normally in my cavity library compared to the standard one that we have. I see questions. Can we copy sketches from that site? Unfortunately not. It works only with AutoCAD or Inventor or SolidWorks. It is possible also with SolidWorks sketches. Today really we do not have enough time to cover also that, but the import of an outline. Let me get back to the filter cavity. It is possible to read from Inventor drawing or from SolidWorks drawing. I always find the reading of the sketch from Inventor and SolidWorks very not always well optimized, so we need to check. AutoCAD works much better. So if you have AutoCAD, it's easier to go for AutoCAD. If not, we can look separately about importing from SolidWorks or from Inventor, and that is doable. We have customers regularly doing outlines. Now the last part, although we are really running out of time, but I want to cover it, so sorry for going a bit longer. I want to cover a bit of topic for insert style valves, orifice plugs, because I see frequent requests coming from customer. So let's start from the block, and then we, well, first I need a couple. Let me import in my library. So as you can see, with the import library, it's interesting because if you miss some cavities, you just import what you need into the library, and then you have everything under control. What you put in the library is what really you need daily, and then the library will slowly be built. Something I have asked to the developer is really the ability to import just a single cavity from maybe another block. That will be very interesting because in this case, you will really load just what you need in a more flexible fashion than an entire library. But let me import the MPT ports because I show you a bit of techniques for MPT orifice, because recently I discovered a problem supporting a customer and I want to give you some workaround. Okay, so let's get back to the block. And let's say that we need just a BSP port of 1x8. I put it here. So an orifice plug is a cavity you put inside another one that is normally used as an orifice, but it can be also a shuttle valve. Later I show you the example of a shuttle valve. So the command is orifice plug. You select just the cavity, and you can select the orifice cavity. In the original library, I had selected M6, M8, and when you click OK, this cavity will be just merged with the other one, and then you have a cavity which is combined, and this becomes a two-step cavity, a two-port cavity. If you need to change the depth, you go to Edit All Parameters. So let me do again. Click Edit All Parameters. And by clicking here, you can change the depth. So you can decrease or increase the depth. Let's say 20, okay. Or also change the depth, increase it, 40, and okay. This may not be always so precise, and this is something that I notice in the machining drawing, because since the drill is added at the end of the chamfer, then the dimension is not always precise. There are also some decimal places which I don't like. So sometimes I need to manually fix. But recently I discovered another problem with the NPT ports. So if you try with a small diameter to add an NPT 1x16, which is pretty common as an orifice, then there will be a cavity failure. It's not always happening, but this is it means that there is some problem with the sketch definition of this block. As a workaround, and this is also solving another problem for the precision, if you want to add an MPT 1x16, NPT, NPTF 1x16 in a cavity, first change the angle to 90 and then add the orifice plug. That's just a workaround, it will work. And the other advantage of this is that you will be able really to control the depth of that MPT port more efficiently, because then it's really a precise position, and we can make it 30. And I think I'll use the same technique also for metric orifice plugs, because then I really can control much easily the depth, because otherwise here the depth is calculated from the intersection between the cone and the starting point, and I really like to have very as less decimal places as I want. So this is a technique for orifice plug. Please notice that this cavity becomes a two-port cavity, but originally in the library manager, if we look at the orifice cavity, this is a port. So an orifice cavity is defined as a port. So it's a one-way cavity that becomes a two-way feature when it's connected to the parent cavity. Similarly, the same technique can be used to handle insert style check valves. So I had a small example of insert style check valve. This is like a Parker RK RB. Those are cavities that really fit normally inside the standard BSP port, and there is the equivalent UNF port and similar. So normally when I use these valves in my blocks, I have two possibilities. And one is the valve will fit inside a standard BSP cavity like this. So let me sketch it manually. So here is the manifold face, and you put the valve inside here, and then you have the fitting on top, which goes, and maybe you can have also other connection. So if you use this, and this is the check valve, so this is port 1, this is port 2, and there can be another port 2 in the fitting or a plug. If you use this geometry, then you will need a two-way cavity. But the same valve can be used inside another port, maybe of a different size. So maybe you have a larger port, something like this, a larger port, larger BSP port, and then you put inside the check valve here. So you have two different threads. And so in this case, you will go for the orifice geometry. So for this kind of situation, I'll model two type of cavities. So first, I go back to let me create a sample. Well, let me create a new type of cavity here in the orifice plug. I do add, import. I import my BSP port 1x4. My cavity does not need really the step 0. And that's it. And there you can put all the information you want, and the insertion tab is this one. So that's one geometry, and normally this drill is much smaller. Let's say it's like this. So this is like we have the 1x4 BSP thread, we have the step 1, which is the tap drill, and then we have the pilot drill that goes into the cavity. And there you can define the geometry as you wish. In this case, the step 2 is not there. There is no spot face. And we can put the step 1 and the thread. And we can call it G1x4 insert and save it. So now I want to use it into my block. So one scenario is that valve is going to be used inside a larger port, let's say a 1x2 port. The port is maybe called A1, and it's somewhere in my block. And I may need to stretch the drill up and down where you want, and then you put the valve inside. So if you do that, you do the orifice plug, select it, and take the orifice plug, which was the G1x4 insert, and click OK. And now the cavity is merged into the other, and what happens is that we have a two-port cavity. And of course, you can define networks so that they get colored. And with the same command, like we were using for the orifice, here we can change the depth. So we can sync up and down. In case of where you really modeled don't have different threads, then there is no way to use the orifice plug command. So instead of building from scratch, I show you a cavity that I have in my standard library to show you as an example. And I have it into my BSP plugs, and it's the same cavity, VUI 14X. I just gave a check valve. So this is a small, it's the same cavity for like RK1, so Harvey Parker and all the other. So as you can see, the cavity is modeled with just one single thread and 2 ports. This is a different cavity. I show you how it is modeled. It's like this. We can define net names. In this case, the cavity can be synced more or less. The command is the same, stretch cavity step. This will be always available, and it is possible to sync it more or less. But it's important to notice that this geometry can be reached only if you model it into the library, and not it cannot be used with the orifice plug command. So a check valve insert style, and there are similar flow regulator insert style, may work into 2 fashion. One is when the cavity is placed inside a larger cavity, you can use the orifice plug, and when the cavity is placed on the same thread, you will need to model a 2-way cavity. In my standard library, since I frequently need to use orifice plugs inside a port, maybe you put an orifice plug below a test point, I have, for simplicity, created libraries like this. Let me switch to my standard library. And I go to my BSP ports. I have built this kind of cavities, so where I have really a port with already the M6 plug, or if I go to my orifice plug command, orifice plug cavities, that's an example of a plug plus the orifice. So instead of always using the insert orifice command, since it's a very frequent situation, I have modeled a cavity like this, where I have the plug and the orifice inside as modeled as a 2-way cavity. This is really up to how you want to do, and you should really be able to understand the behavior of the library together with the MDTools in order to save time and get the result that you want in the machine drawing. The last example I want today, and really I'm sorry for going longer, is there are components like this HyDraw valve, this one. Those are shuttle valves, so 3-way valves that behave like insert style valves. And the scenario is really the same. It applies the same behavior. But in this case, really what you need to do is you need to model, and recently I supported a customer on the same exact topic for a different valve, for a Eaton Vickers valve, which is an M10. This is 1A1/8 BSP, but this is in that case it was a M10 valve. So as you see, it's 1, 2, and 3. This is going to fit into a 1/8 BSP port made something like this with a flat plane, and then we have the drill. So and on top here you could have another drill, and here you could have the same 1/8 BSP thread or a larger one. So what you need to do in this case is really use the same orifice plug command on a 2-way cavity, 1, 2 cavity. So what I do into my library is to model this is the shuttle valve. So here I will assemble the cartridge. So the first part is the thread, and then we have the geometry. And this item will enter inside another construction port or another port in the block. So if I go back to my MDTools and want to use that insert valve, I'll, for instance, insert a plug, maybe a 1/4 BSP plug, somewhere here. And then I'll use the orifice plug command to add the insert style shuttle valve, which has 2 ports. Maybe this is going to be P, this is taking the LS, and OK. And this is now creating the valve with 3 ways. So we start from a 2-way geometry to get the third from the source cavity that was in the block. A common support request I get, and it's really always simple to answer, but since it's common, let me clarify here also. The orifice is added below the last step of the actual cavity in the block. So if this drill is 8, you will not be able to insert an M8 orifice. You will get an error. The orifice spot face diameter is greater than the minimum diameter of the first cavity. So if you want an M8, this drill must be larger than M8, maybe 8.05, that's okay. And now it will work, but it must be larger than that M8. Otherwise, you will not be able to put. You cannot expect to put the orifice in between. You will need to put the orifice at the end of the cavity that you have. So make sure the diameter is larger. So again, sorry for being longer, and but I hope that you found the information useful. And if you have other topics for library management, feel free to ask, even with support, and maybe we set up another session. I cover all the topics I had in mind for this, but again, sorry for being late. I turn it over to Frank.
All right, thanks, Carlo. So that is all the time we've got today. If your question didn't get answered, we'll follow up with you via email within 24 hours. If you think of any follow-up questions after the webinar, please send us an alert email to support@bestusa.com with any further details. I would like to thank Carlo again for giving today's product topic demonstration. We'd be grateful if you could complete a short survey at the conclusion of today's webinar. Also, tomorrow you'll receive an email containing a link to view a replay of today's session. Feel free to share this link with your colleagues. A link to view video segments from prior webinars will also be provided in that email. As you can see, we also have the webinar series posted on our various social media channels. We invite you to follow these channels so that you can receive the latest updates on upcoming webinars as well as product releases. Our next webinar is scheduled to occur Tuesday, February 27th, where the ability to build and use a custom library of symbols and data to create schematics on a web browser will be demonstrated. Thanks again, Carlo, and thanks everyone for attending today's session. Have a pleasant and safe day, and we look forward to your feedback on future webinar topics, which can be reflected in the survey that will launch shortly.